You are holding a rock. It is black, smooth, and sharper than anything else you have ever touched. You did not make it. You found it near a volcano, wedged into a ridge of coarse gray stone, and when you cracked it against another rock, it broke into a curved edge, so thin it could slice skin, without you feeling it. This is obsidian / volcanic glass, roughly 700,000 years ago, at a site called Kariandusi in Kenya's Rift Valley. A human ancestor, Homo erectus, picked up a piece of this same material and used it as a tool. That is one of the earliest known moments. A human held glass, not a window, not a drinking cup, not a lens. A rock that happened to form when lava cooled too fast for crystals to arrange themselves. Glass before humans. Glass existed on this planet for billions of years before anyone figured out how to make it. Lightning struck sand and left behind hollow tubes of fused silica called fulgurites. Meteorite impacts melted entire desert floors into sheets of pale yellow crystal. Volcanoes poured out rivers of molten rock that cooled into obsidian fields. Nature had been making glass since before life existed. Hundreds of thousands of years passed, and humans used it the entire time, without once understanding what it was, or that they could make it themselves. They carried it, they shaped it, they cut with it, and never asked the one question that would have changed everything. Where does this come from, and can I make more? That question sat unanswered / for longer than agriculture has existed, longer than cities, longer than writing. The question, so how did we get from a volcanic rock to the screen you are looking at right now? The honest answer is that nobody planned it. / This is a 5,000-year story, and buried inside it are at least 3 accidents. 3 separate moments when someone was trying to do something else entirely, and glass happened anyway. The last one might be sitting in your pocket right now. Before any of those accidents happened, though, humans needed to understand what glass actually was. For most of history / they got that badly wrong. The liquid myth. You may have heard the old claim that glass is a liquid that flows very slowly, that the windows in old cathedrals are thicker at the bottom because the glass has been oozing downward for centuries. This is a myth. Physicist Edgar Zanotto at the Federal University of São Carlos in Brazil calculated in a 1998 paper in the American Journal of Physics that it would take longer than the age of the universe, more than 13.8 billion years, for cathedral window glass to show any measurable flow at room temperature. The uneven thickness of old cathedral windows has a much simpler explanation. Medieval glassmakers spun molten glass into flat discs, and the discs were naturally thicker on one edge. Glaziers installed the heavy side at the bottom, because that is where heavy things go. The glass never moved. It was made that way. What glass actually is? What glass actually is turns out to be something genuinely strange. It is an amorphous solid. Its atoms are arranged in a disordered pattern, like a liquid frozen mid-motion, but it has the rigidity of a solid. It never formed a crystal structure. It skipped that step entirely. Cool most liquids slowly, and their atoms line up into neat, repeating grids. Crystals. That is what happens with ice, with salt, with metal. Cool certain liquids fast enough, and the atoms never get the chance to organize. They just stop moving while they are still tangled. That is glass, a material caught halfway between 2 states of matter, permanently stuck in the moment of transition. Physicists still do not fully agree on how to classify it. The recipe. That in-between quality / is part of what makes glass so useful. It can be transparent, shaped, colored, made thinner than a human hair, or thicker than a bank vault wall. It starts with sand. The main ingredient in most glass is silicon dioxide, the primary component of common sand. Pure silica melts at roughly 1,713 degrees Celsius, far too hot for any ancient furnace. Add a flux, though, a material that lowers the melting point, and the temperature drops to something manageable. Ancient glassmakers used natron, a mineral made mostly of sodium carbonate, mined from dried lake beds like Wadi Natron in Egypt. Mix sand with natron, heat it to around 1,000 to 1,100 degrees, and the silica melts. There is a catch. Glass made from just sand and natron dissolves in rain. Add a stabilizer, usually lime, from crushed limestone or seashells, and it holds. Roughly 70% silica, 15% soda, 10% lime. Give or take a few points. That 5,000-year-old formula. Is essentially the recipe still used, for most glass produced on Earth today. One origin or two? Here is the question that matters. Who figured this out first? Did it happen once, in one place, then spread outward, or did two civilizations stumble onto the same trick without knowing the other existed? Hold on to that question. The answer will not come for a while. And when it does, it comes from chemistry, not legend. The Phoenician myth. The Roman historian Pliny the Elder, writing in the 1st century AD, told a story that has been repeated for 2,000 years. Phoenician merchants, camping on a beach near the river Belus, in what is now Israel, rested their cooking pots on blocks of natron they were transporting as cargo. The heat of the fire combined the natron with the beach sand, and molten glass flowed out from under the pots. It is a wonderful story. It is also almost certainly false. An open beach fire reaches maybe 600 to 800 degrees Celsius. Even with natron lowering the melting point, that is nowhere near hot enough to produce glass. Pliny's story is a foundation myth, not a scientific account. The real origin is messier, less romantic, and considerably older. Accident number 1. The earliest man-made glass objects are small beads found in Mesopotamia and Egypt, dating to roughly 2500 to 2300 BC, over 4,500 years ago. Here is the first accident. Wilts, the most widely accepted theory, is that glass was discovered while people were making faience, a quartz-based decorative material coated with a glassy glaze. When silica-rich materials mixed with alkali flux inside a hot kiln, the surface sometimes vitrified, producing a thin layer of actual glass. At some point, someone noticed that this glassy skin could be scraped off and used on its own. A second theory, from archaeologist A. Leo Oppenheim's landmark 1970 study on ancient Mesopotamian glassmaking, points instead to the glassy slag left over from copper smelting. Either way, nobody set out to invent glass. Someone was making something else entirely and got glass as the leftover. That is, accident number 1. And it is also, when you think about it, how a surprising number of history's most important inventions actually happened. A luxury fit for kings. For the first 1,000 years of its existence, glass was not a common material. It was a serious luxury. During the late Bronze Age, roughly 1550 to 1200 BC, glass was valued alongside lapis lazuli, turquoise, and gold. Diplomatic letters found at Tel el Amarna, correspondence between Egyptian pharaohs and other Near Eastern rulers around 1350 BC, include complaints about the quality of glass sent as gifts. One ruler wrote to the pharaoh, in essence, that the glass he had received was terrible. Heads of state, arguing over glass, the way modern leaders argue over gemstones. That is how rare it was. The workshop at Amarna. The most important ancient glass workshop ever found sits at Amarna itself, the short-lived capital built by Pharaoh Akhenaten around 1350 BC. W.M. Flinders Petrie first excavated the site in 1891 and found glass rods, canes, ingots in multiple colors, half-finished vessels, and the remains of furnaces. Later excavations by Paul Nicholson of Cardiff University between 2004 and 2007 showed that Amarna's glassmakers used a two-stage process. Raw materials were first melted into a rough mixture called frit. Then the frit was crushed and remelted at a higher temperature to produce clear, bubble-free glass. That is not a simple operation. That is industrial chemistry performed 3,400 years ago. The scarab from the sky. Khi chú diễn xuất, đây là đỉnh cảm xúc đầu tiên sau phút 12, giữ nhịp chậm, để sự kỳ diệu tự nhiên hiện ra qua khoảng lặng, không cần nhấn giọng kịch tính. In 1922, Howard Carter opened the tomb of Tutankhamun and found a carved scarab beetle set into a ceremonial breastplate. For decades, it was identified as chalcedony, an ordinary gemstone. Then in 1998, Italian mineralogist Vincenzo de Michele examined it with infrared spectroscopy and confirmed something stranger. It was Libyan desert glass, a pale yellow-green natural glass, found scattered across the Great Sand Sea on the Libya-Egypt border. It formed roughly 29 million years ago, almost certainly from a meteorite impact or a cosmic airburst, hot enough to melt desert sand into glass. Egyptian craftsmen found a piece of that glass lying in the sand, thought it was beautiful, carved it into a sacred scarab, and set it on the chest of a dead teenage king. They had no idea it had formed millions of years earlier, in a burst of heat from the sky. They just thought it was beautiful, and that was reason enough. One method, 15 centuries. The earliest glass vessels were not blown. They were made by core forming, a technique that appeared around 1500 BC. A craftsman shaped a core of clay and dung around a metal rod, dipped it in molten glass, or wound hot glass trails around it, smoothed it on a flat stone, then scraped the core out once it cooled. Small, colorful, beautiful, expensive, and for more than 1500 years, it was the only way to make a hollow glass object. Every vessel on Earth made one at a time, by hand, for 15 centuries straight. The breath that changed everything. Then, sometime around 50 BC, on the coast of what is now Lebanon or Syria, someone put a blob of molten glass on the end of a hollow iron pipe, and they blew. Glass blowing did not need an accident. It needed one idea, applied at the right moment, and it is one of the most transformative technological leaps in human history, one almost nobody talks about. Before it, a single glass vessel took hours of skilled labor. After it, a trained craftsman could make one in minutes, dozens in a day. Vessels became thinner, lighter, larger, and genuinely transparent for the first time. Glass stopped being a luxury reserved for the elite and became something an ordinary household could own. The earliest blown glass has been found in Jerusalem, dating to the mid-1st century BC. One of the earliest named glassmakers in history, a Sidonian called Ennion, active in the 1st century AD, produced mold-blown vessels and signed them in Greek. Ennion made this. His work has turned up from Israel to Italy. The Metropolitan Museum in New York holds one of his pieces. He was not just a craftsman, he was a brand. Stamped onto a cup 2,000 years ago. The Romans did not invent glass blowing. but they industrialized it, the way they industrialized everything. Within decades, workshops from Cologne to Alexandria were mass-producing bottles, cups, bowls, and jars. The writer Strabo noted, around 20 AD, that glass drinking vessels could be bought for a single copper coin. Glass had gone from rivaling gemstones to costing less than a meal. And the Romans used it for something nobody had tried before: windows. Evidence of Roman window glass survives at Pompeii, preserved under the ash of 79 AD, small, thick panes that let in light while keeping out the weather. Someone had to invent the idea that you could see through a wall. The Romans did. Roman nanotechnology. The Romans also made something modern craftsmen still struggle to replicate. The Lycurgus cup, now in the British Museum, is a 4th century cage cup that changes color. Lit from the front, it looks opaque jade green. Lit from behind, it turns translucent ruby red. In 1990, researchers at the British Museum, including Ian Freestone, examined it under a transmission electron microscope and found gold and silver particles roughly 50 to 100 nanometers wide, far too small to see with the naked eye, creating the color shift through surface plasmon resonance, the same physics researchers now study for medical diagnostics. The Romans built. Nanotechnology. 1600 years before anyone had a word for it. Guarded secrets. For the next 1,000 years, glassmaking kept moving. Islamic workshops across Syria and Egypt, working between roughly the 7th and 15th centuries, mastered enameling and gilding techniques European glassmakers would not match for centuries. Then, in Venice, glass became a state secret. In 1291, the Venetian Republic ordered every glass furnace moved to the island of Murano, officially for fire safety, really to guard trade secrets. Murano's glassmakers were given extraordinary privileges. They could carry swords, their daughters could marry into nobility. They were also forbidden to leave the Republic, on pain of consequences for the families they left behind. Around 1450, a Murano glassmaker named Angelo Barovier developed cristallo, nearly colorless glass of a clarity Europe had never seen, made by carefully purifying his raw materials. It cemented Venice's reputation as the undisputed capital of glassmaking, a reputation other countries spent the next 2 centuries trying to steal. Glass gives scholars their eyes back. Eyeglasses were invented in northern Italy, probably Venice or Florence, around 1286. The 1306 sermon by the friar Giordano da Pisa mentions that the art of making eyeglasses was not yet 20 years old. Historian Vincent Ilardi has argued that spectacles extended the productive reading life of scholars by 15 to 20 years, effectively doubling the working career of anyone whose eyesight failed with age, which was nearly everyone, by their 40s or 50s. When the printing press arrived around 1452 and flooded Europe with books, the two fed each other. More books meant more readers needed glasses, and more readers with glasses meant more demand for books. Without glass, mass literacy might have arrived generations later than it did. The sky through glass. In 1608, a spectacle maker named Hans Lippershey filed a patent for the first telescope. The following year, Galileo Galilei built his own improved version, pointed it at Jupiter, and watched 4 moons orbit the planet. He published the observation in March 1610. 4 dots of light, moving around a point that was not Earth, and the geocentric model of the universe, the one everyone had accepted for 1,000 years, did not survive it. Everything revolved around Earth, until someone looked through 2 pieces of curved glass and proved that it did not. The drop of water. On the other end of the scale, a Dutch draper named Antony van Leeuwenhoek with no formal scientific training, ground tiny, near-spherical glass lenses that reached magnifications of up to 275 times. Looking through them, he became the first person to see bacteria in 1676 and spermatozoa in 1677. He called them animalcules, little animals, and described them in letters to the Royal Society in London. Modern microbiology begins with a self-taught cloth merchant grinding glass in a workshop in Delft. Two pieces of shaped glass, one pointed at the sky and one at a drop of water, and between them, they showed that the universe was larger and smaller than anyone had imagined. One invention or two answered. Remember the question from earlier, did glass get invented once or twice? In 2012, archaeologist Andrew Shortland of Cranfield University used laser ablation mass spectrometry to analyze the chemical signatures of early Egyptian and Mesopotamian glass. What he found, the Egyptian glass carries trace element fingerprints consistent with Egyptian raw materials. The Mesopotamian glass carries a different fingerprint entirely. That is not proof one region copied the other. It is closer to the opposite, chemical evidence that two civilizations working with the same basic ingredients under the same kind of kiln heat arrived at the same discovery on their own, without contact. Nobody can say with certainty exactly how many times the accident happened, or in how many other kilns it happened and left no trace. What the chemistry does show, is that this was not a one-time fluke, tied to one lucky furnace in one city. Give any Bronze Age civilization the right raw materials and enough kiln heat, and sooner or later, the accident finds them. Accident number 2. Jump forward 3,000 years. In 1903, a French chemist named Edouard Benedictus knocked a glass flask off a shelf in his laboratory. It hit the floor and cracked, but it did not shatter. The pieces stayed together, held by a thin film he realized was dried cellulose nitrate, left behind from a solution that had evaporated inside the glass. He filed a patent for laminated safety glass, in 1909. Its first major use was gas mask lenses, in the First World War. Today, every car windshield on Earth is a descendant of a flask that a chemist knocked off a shelf by accident. That is, accident number 2. A river of glass on a river of metal. In 1952, engineer Alastair Pilkington at the Pilkington Brothers Glass Company in St. Helens had an idea that had nothing to do with an accident and everything to do with patience. Pour molten glass onto a bath of molten tin. Glass floats on liquid tin, spreading into a perfectly flat sheet under its own weight, cooling into a continuous ribbon with a mirror-smooth, fire-polished surface. It took 7 years and roughly £7 million to perfect. Pilkington Brothers announced the float glass process on January 20th, 1959. Today, over 90% of the world's flat glass is made this way. Nearly every window you have looked through was floated on liquid metal before it ever held still. The internet is glass. In 1966, engineer Charles Cow and his colleague George Hockham proposed something that sounded absurd. Thin strands of ultra-pure glass fiber could carry information as pulses of light. The obstacle was purity, the best fiber available at the time, lost so much light over distance that it was useless for communication. Cow's insight was that the loss was not a fundamental property of glass. It was caused by impurities. Purify the glass enough, and light could travel for kilometers. In 1970, researchers at Corning Glass Works produced the first optical fiber pure enough to cross that threshold. Today, hundreds of millions of kilometers of fiber optic cables run beneath the ocean floor and across continents, and more than 95% of international internet traffic travels through glass threads thinner than a human hair at the speed of light. The internet is not metaphorically built on glass. It is physically made of it. Cow won the Nobel Prize in Physics in 2009 for making that possible. Accident number 3. In 1960, Corning developed an experimental chemically strengthened glass they called ChemCore, made scratch-resistant through an ion exchange process. It tested well. It never found a market. For 45 years, it sat in a filing cabinet, forgotten. Then, in 2006, Apple was building the first iPhone and needed a strong, scratch-resistant glass for the touchscreen. Corning's CEO, Wendell Weeks, remembered the dormant ChemCore project and told Steve Jobs about it. Jobs was skeptical. Weeks reportedly told him not to say what Corning could not do. Corning reformulated the old formula, renamed it Gorilla Glass, and delivered it in time for the iPhone's launch in June 2007. A Cold War-era glass technology, shelved for nearly half a century, ended up in your pocket because two people had a conversation at the right moment. That is, accident number 3. And it means the screen in your hand right now is not so different from the volcanic rock at the start of this video. Both are glass that a human found sitting somewhere, unused, and decided to pick up. Someone looked closer. Coda. Glass is sand. That is all it has ever been. Heated sand, shaped by human hands, cooled into something transparent. From that one material, humans built lenses that revealed the structure of the universe, fibers that carry the sum of human knowledge under the ocean at the speed of light, mirrors that let you see your own face, windows that let you see the world without feeling the weather, a scarab carved from a 29-million-year-old cosmic impact and placed on the chest of a teenage king. 3 accidents 5,000 years apart, all involving the same species, doing the same thing, paying attention when something strange happened in a fire. A byproduct in a kiln in the Bronze Age, a flask that would not shatter in a Paris laboratory, a formula rediscovered in a filing cabinet. You are surrounded by glass right now. You are surrounded by glass right now. You are almost certainly looking through it. And the only reason any of it exists is that someone, somewhere, at least 3 separate times, noticed a thin, shiny substance forming where it should not have been. And instead of scraping it away, they looked closer. That is the entire history of glass. Someone looked closer. 3 times, that was enough.